door skin replacement is going to be what I call accelerated. It's highly prepped. I want to get to the real important parts, but we'll talk through initially the basics. Some of what I'm going to be describing deviates a little bit from the current printed protocol, the procedures that are provided with the parts. I've proven that it works. You know, it's like skinning a cat. There's a lot of different ways to do it. It's what works best, gives you a quality repair at the end, and I think what I'm going to show you is just a quicker way to do it that will give you a nice, robust repair. As with any door skin, doors off the car, typically, want to grind the edge. That's the fast way. Grind right around that door. On the forward doors on the F-150, you literally have 2-inch butt joints that are really simple to make. We're not going to do that welding today. We're going to get to that point and that'd be a simple finish up. But your rear butt joint is covered by a reveal molding. So very fast, very simple. Safety and gloves is critical. We all know that. You cut your hands up, you get stuff in your eyes that may never come out. This door, I've done the perimeter grinding of the rollover hem. That falls off once it's ground. The intersection falls off, or it sticks a little bit to the sealer, generally pops off. Do some very simple cutting up at the top. Be strategic about where that location is at, so you can keep it capped underneath the molding, or make it in the smallest section, so the shortest distance. That makes it simple. If you start doing big, long butt joints, those become very difficult to keep flat to the panel. Once the panel is released on the edge, we've got the adhesive underneath. Multiple ways to do it. What has worked really well for me is this flat chisel tool. Get about 6 inches into the door, you can grab it and start to rip it, or keep tapping it, it depends. Once the perimeter is broken loose, the anti-flutter in the center will tear right off. You could apply some very low heat. It may soften the adhesive a little bit, but this is a pretty fast operation. At that point, we take off the outer panel, and you want to prep for the actual installation. So what we want to do is to clean off the adhesive on the edge minimally as possible. You have E-coat that's come up all the way to the original bond line. We don't want to disturb that. All we need is a little bit of adhesive to hold the panel in place. The adhesive is basically holding it in a dimension, right? Once it kicks off, it just locks that door in place. It's not there for a crash mode. It's there to hold the skin, it's there for NVH, it's there for corrosion. That's the purpose on a door. The anti-flutter obviously is just to avoid that tin canning on the outer panel. We'll apply that after the fact. When the outer is off, typically you'll undercut your existing panel on the door, take your new service panel, apply it, and you'll do your final trimming for the belt cut, for this butt joint up here. If you try and pre-cut everything perfectly, odds are you're going to be a little bit shy here and there, and then you're trying to fill it up with weld. The door frame itself, once you've deskinned it, if the door shell inner is damaged, now we're going to straighten that out. You can use both the inner shell and the outer panel to determine where everything should be. But you're repairing to make it all fit. So if the shell is maybe crushed in the corner, pull it back, hammer work it, bring it out to the skin. Vice versa, the skin wants to align pretty well with the shell, but you've got maybe 1/8 of an inch play left to right. When we get to the point that we've actually hemmed it and you've got adhesive in the joint, the adhesive up until the point that it begins to cure is actually a lubricant. So if you skin on the stand here, we're going to want to put it up onto the body, check fit. If we're off, relatively simple with some very, very light tapping to get that outer skin to float back and forth and set it perfectly in the door opening hole. And that's the critical part. It needs to align right to the roof and then fender and rear door. If you've got 2 doors going on, you may want to put the existing damaged door back in place to set that. With adhesives, and this applies to anyone's adhesive, a couple of key steps to avoid not having a failure. And if there's one problem that we deal with from the standpoint of technical support, it's that the adhesive didn't cure right. It cured soft, it cured slow. So again, regardless of whose product you're playing with, any of the two components, there's two steps you need to go through. You need to level the plunges. These are packaged, they're very close to being exact side to side. You always pre-purge a little bit of material, be it adhesive to component, seam sealer, etc. Get things level, put the mixing tip on, and then you're going to extrude a little bit of material into the garbage. That ensures that you've got the correct mix coming out of your mixer. Now you're going to be consistent from the start of the application to the end in the cure rate, strength, etc. I already leveled it ahead of time. Now we'll just start mix up a little bit, and we'll get to what is, to me, the most important and challenging part is the hemming. Anybody can put the adhesive on. I'm not teaching you something new here. But it's when we go into the hemming operation, this is critical, right? That's where you can destroy, have a panel that starts to crack. Adhesive, because it's also providing corrosion protection, I would tend to lean on the heavy side. It actually takes a very small bead once you compress it to fill out onto the panel. If you put excess in there, it will come out. It's something you got to wipe up. But at least you know 100% that you had adequate squeeze in that joint. If you're not seeing a little bit of squeeze out, then you don't know if you even had enough adhesive in there. The difference in volume that you're going to apply is literally way under an ounce, so it's insignificant. So real quickly, we'll put this on. Up at the top where we're going to do the actual welding for the belt cut, want to end up with adhesive about an inch away from that weld. So you probably stop at about 1.5 inch point. You're going to have some squeeze of the adhesive upward. Down in these corners, just inherent with the way that the original adhesive was in there, put a little extra so we know that it squeezes back up into the door. When you're using any of these adhesive products, in this case I'm using the kind of a cut-resistant glove. If I wasn't using this, you do want to have some kind of a rubber nitrile glove on. You just don't want the chemicals being allowed to soak into your skin. With the anti-flutter material, there's two schools of thought. One is that we would put something in post-assembly that will foam up heavily, fill that gap. The flip side to that is to put more of a heavy-bodied NVH compound in there and put the skin on, and it'll hold it together. Again, it comes down to personal preference. After you've played with both of them one time, typically you'll figure out which works best for you as an individual and in your overall process of popping the panel in. On the inside of the panel, what I didn't show you is a little bit of prep. You want to break the E-coat in that bonding zone so that the adhesive goes to metal. That gives you the most robust bond joint. The adhesives will, in fact, stick to the E-coat. However, they're designed to go metal to metal for the most strength. Once it's fit, your choice of clamps, multiples on the market. I'm not trying to sell any clamps, but actually just got these this morning. I had a chance to play with something like this the other day. Very handy. Want to start at the bottom, pull it taut, and then we'll fix it going up. Not too much pressure. You don't want to do any damage to the skin you're installing. Just enough to hold things in place. Once we go into the hemming operation, we're going to be beating on this hard enough that it's wanting to move around. This is just going to keep us oriented on the door. In this case, something you can't see is up at the top here. There's a hole that the belt molding aligns with on this vehicle. Whenever you have something like that, that's where you really want to try and use it as your orientation for your panel replacement. I have cut the new panel directly to the bottom of that hole. I know that that's my reference point. So as long as I set it up as we clamp forward, line up with that hole, it's going to be where the old skin was at, precisely. One down here, one right up here on the flat. All right. This is the tool prescribed to do the hemming operation. This is a tool made by OTC, and it will initially form a smooth bend over, and then as we get into the final closing, it creates, instead of a sharp hem, it creates a rope hem. So the outer panel has like a little bit of a rope underneath it. Personally, I find using this tool is laborious. You have to really beat on it with a large hammer to get the door to begin to hem down and then roll over. In preparation for this, I purchased a tool created by Stack with the air chisel, right? Everything is about speed in collision repair. It's how you make money. What I found, it wasn't just fast. I felt, for me, it actually did a better job. I didn't like the idea of using literally a 4-pound maul beating on the door. It takes 2 people to do this. When you're beating on it with a hammer, it's like 3 people. It really becomes unfun. There are 2 versions of this. This is what I'll call the wide flat. Then there's another version I've got on the table that gets into some of these nooks and crannies. This, if you're doing a belt cut, you can do the whole panel with it. With the exception of maybe right up here, which you can go back to the hammer and dolly. Hammer and dolly is still going to be used in some of these contoured areas where you don't have a big long hem, it's very tight. They're just barely rolled over, so handwork goes after we've got the hem in place. So when you do this, pick your favorite locations. I like to lock things down, 4 corners, then we'll spin it over and do the true hemming. Close up the bottom, then we'll do the sides, keep it in position. The way this works, you come at it 90 degrees straight, you initiate the bend, you bring the tool around 45 degrees, now you're doing that full rope. Again, all we're doing for right now is just locking it, a couple key spots. Got a nice rounded edge on the hemming, and we pulled it tight. So we'll start on the bottom. The delt door shell itself is tight right into the the 90, go across the panel, do the initiation, then come back, do the full hem, pop the clamps out of the way as needed. So you do like 2 passes at 90 degrees, and that does this to it. Takes it down a couple steps. Then we rotate at the angle, and it clamps it right down tight. Be warned, using a tool like this shaft is going to get so hot it'll burn you, seriously. You'll typically find out, like I did when you grab it, it's too late at that point. We've got some good clamp pressure now. We'll take one clamp off, work this way, go the other way, and we'll bring it up the side, avoiding in these corner areas here, the tool will begin to get stuck. So you work to them, we'll come back later, do that, finish it off by hand. We've got some adhesive squeeze out, that's perfect. Now you know for a fact it's in there, we're not wasting a lot of material, and it's going to be sealed up very well. Depending on the angle that you actually pull the tool at, you can get more or less crimp. You want to do just enough. If it's not quite tight enough, then you just rotate upward. That hem's closed. It's got adhesive squeeze out. It's done. With aluminum, even though it's E-coated, you have to have your tools separated. Otherwise, there is that cross-contamination. Everybody tech here knows that's a hemming hammer. My favorite, it's a chisel point. This is what we can work in these corners and get it smoothed out really nice. This is not a class in body repair. Everybody tech do this way better than I do, I guarantee that. At this point, we'll finish up the edge, do the butt joint. This door is basically done. A little bit of fill work on the front exposed. Well, rear will clean up and it'll be hidden by the belt line, so maybe just a little quick cosmetic fill and done. Effectively, that's replacing a skin. Not a lot of tricks to it. Really nothing different with an aluminum versus steel, other than we've got our tool sets that are separated. In the case of the hemming tool, the tool is designed for aluminum. It's red, very easy to keep separate. The key is the adhesive. You've got to have that in there for the NVH, for the dimensional. And one of the big concerns with aluminum is the potential for corrosion. If it's sealed up in this fashion, there is no issue, right? The issues are the same between any metal on the road. For those of us in the northern climates dealing with salt, that's where corrosion is the biggest issue. Going south, you really have to avoid galvanic corrosion, the similar metals. You don't have that here. You just want to keep it clean.